good day, everybody. I'm Isaac Treves. I'm a product manager for Cocos Hypervisor SDK at Open Synergy. For those of you who are not familiar with Open Synergy, we are a small company specialized in automotive virtualization based in Berlin, Germany. Don't be fooled by my accent. I am actually based outside of Berlin, Germany. Okay, two disclaimers before we start. One, it's 7:30 here and I have two children, so they may burst in at any time. And two, as you can see from my title, I am a manager, which means I am quite clueless and I didn't bring any of my developers along tonight. So if you have deep technical questions, we'll have to take those and get those answered after the fact. But let's dive into it. Today we're going to talk about Android Trout. Okay, so let's see. What's for lunch in the automotive world of Android? Well, you've got Renesas lunch targets for Renesas platforms. You've got Samsung lunch targets for Samsung platforms, Qualcomm, NXP, and others as well, NVIDIA, MediaTek. So, there's a million hardware platforms out there that you would want to deploy Android in automotive. I heard before Chris's talk about, Android on RISC-V. That would be more lunch targets, more variants, and, eating an Android lunch target for each hardware platform will make any software organization fat, right? Keeping all of these different Android variants is a real pain from a maintenance perspective, from a porting perspective. It's just something you want to do. So what's the solution? Well, the solution is to stay fit by swimming towards a software-defined architecture with Android Trout. Okay, so let's talk a little bit about software-defined architectures and what we mean by that, at least at Open Synergy. So in the old days, the hardware defines the software. That means you have a function, let's say it's an Android infotainment system, and that Android infotainment system is tailored to the hardware. That means you need a special lunch target for that hardware, and if you want to move that infotainment function from one hardware to another, you have all kinds of porting effort. But with a software-defined architecture, we put an abstraction layer between the hardware and our function. So for example, our Android IVI system, and this way the software defines the hardware. So since the software doesn't see the hardware, we can move that software onto any hardware with zero porting effort, zero problems, and we only need one software variant for our whole zoo of hardware that we may want to deploy in the vehicle. Okay, let's talk a little bit about VirtIO. Chris mentioned it. I don't know how many people, if VirtIO is known to everybody, so let me give a short overview.
Sure.
So it was developed in 2008 and is managed by the AOSP Open Consortium. You can find them on the internet. It's supported by all cloud and enterprise hypervisors. It's a standardized interface for input-output between virtual machines and hypervisors. Drivers are widely available in major operating systems, including in the Linux kernel. So the AOSP Open Consortium upstreams VirtIO drivers into the Linux kernel. So essentially, you get VirtIO support in Android out of the box. More and more devices are becoming available for the automotive domain, for example, audio, sensors, graphics, camera, and CAN. So it used to be that VirtIO at the beginning came from the cloud space and only supported essentially network and block device. But the AOSP Consortium, in conjunction with the automotive industry, has expanded out to devices that are needed for automotive use cases, for example, graphics. All right, let's talk about some of the VirtIO devices. So you see here in the first version 1.1, there was network, block, console, entropy, so random number generated needed for Android to boot, for example. GPU 2D is nothing other than the display controller, input for touch, and sockets. And the new version will add sound. Car radios had sound in 1929, so they should in 2022 as well. Video playback using the hardware codec. Sensors, for example, the gyroscope or the GPS sensor. And of course, GPU 3D, which also Android won't run without. So the AOSP Open Consortium adds automotive-specific device interfaces to the standards, as does Open Synergy. We provide high-quality drivers in upstream to the Linux kernel, so we upstream these VirtIO drivers to the Linux kernel along with Google. And there's a virtual machine ecosystem that guarantees guest readiness for AGL, Android, RTOS, any Linux-based system, or really any operating system that supports VirtIO. So how does it work? How do you do it? How does this all work from a technical point of view? So basically, here's the setup. You have a Linux here. You have a native Linux, which serves as an execution environment for a VirtIO device implementation. Usually this is the Linux you would get from the hardware vendor, but we also see, for example, Red Hat out there wanting to have an automotive Linux called RIVOS based on the upstream Linux kernel, and we see that Qualcomm is upstreaming most of their drivers now, so it wouldn't necessarily have to come from the chipset vendor. So basically, as long as you can get in a Linux, you can deploy an Android. There was also talk at the beginning again about RISC-V and will Google get Android? Well, if you could get a Linux on there, you could get an Android on there. Chris also talked about Qualcomm working on getting a kernel out to support Android T. We actually already have Android T up and running on Qualcomm at Open Synergy now because of VirtIO. So it also helps you get ahead of the game. So as long as you can get that Linux for the platform or any environment where you have a VirtIO device implementation, you can then run Android. So it's basically like if you have Linux, you get Android or any other VirtIO compliant operating system. Okay, so there's automotive device sharing. So you have a VirtIO device implementation, which is nothing more than a bunch of applications sitting on top of Linux that serve up the actual physical devices to Android. And they use these native device drivers down here. Okay, the isolation of software from hardware, that is done by the VirtIO layer. You have performant virtualization, so a hypervisor that uses ARM virtualization extensions separates Android from other guests with almost no overhead. And really, on the ARM V8 Cortex-A cores, putting systems on a hypervisor incurs almost no overhead because of the hardware assisted virtualization. Okay, and now there's this Android Automotive OS Trout. It's really one lunch target based on VirtIO to rule them all. And I didn't mention it up until now, but Trout is based on Cuttlefish, which Chris also mentioned. So Trout is nothing more than a variant of Cuttlefish, which is meant for automotive use. And its really reason for being is so that we and Google can work faster than Cuttlefish to get Android Trout working in an automotive environment and working with automotive use cases. Okay, automotive safety. So because of virtualization, you could also put other functions on the same SoC as the one where Android is running. So you could put an ADAS function running with your Android IVI system, and you could be sure that your Play Store in Android is not going to mess around with your safety critical ADAS function. And hardware support. So as I mentioned, the ARM V8 Cortex-A cores provide hardware support for virtualization out of the box. So that makes your virtualization essentially overhead free. So looking at this setup, again, this Android Trout with the VirtIO drivers provided by the Linux kernel is essentially accessing the physical devices of the hardware through these VirtIO devices, which again are nothing more than applications running on top of Linux. And that basically allows you to run this AAOS Trout lunch target on any automotive ARM V8 hardware platform where you can get this VirtIO device implementation. Let's look what that means. So it's really a paradigm shift in Android. So before VirtIO, okay, Google did the framework, this stuff up here. Well, that's still the same. According to Treble, it can't be any other way now. You're not allowed to touch this stuff anymore above the hardware abstraction layer. But now it starts to get interesting. We look at the hardware abstraction layer, without VirtIO and Trout, the hardware vendor is responsible for the hardware abstraction layer. So for example, Qualcomm will provide this hardware abstraction layer. But in the new world, now Google is doing this. So up until now, Google had said, okay, there's Treble, everything above the hardware abstraction layer is our stuff except the applications, everything below is the hardware vendor. But now Google is moving down into the hardware abstraction layer. So they actually provide a hardware abstraction layer with Trout that runs with VirtIO. And then looking to the kernel, it's the Google and the hardware vendor, for example, Qualcomm. But if it's with VirtIO, it's the Google kernel.org, of course, and Oasis Open providing those kernel drivers. So again, you've basically kicked the hardware vendor out of your Android, and you have an Android that is totally pure or totally free of any hardware vendor specific stuff. And this works for most devices. Trust zone is a tricky one, as Chris mentioned, from the Linux plumbers. It's very fragmented. There's no standard around it, but most devices work, as I said in the slide before, about what VirtIO devices are supported. Let's talk a little bit about the Android HAL. So if you look, here are the Android HALs and features that are supported in Android Trout. And here is the VirtIO technology behind it. So for example, the audio control HAL, we just use a proprietary socket connection to control the actual DSP, which again, the driver is on that Linux, on that VirtIO host side from the Android guest. The audio HAL, no surprise, VirtIO sound is behind it. For Bluetooth, we have a solution that uses VirtIO console, which is nothing more than a text interface to send host controller interface commands from the Android guest to the host. And then you see dump state. Extended view system is for camera input, which is becoming very important in automotive. We use VirtIO video for that because a camera stream is nothing more than video. We support garage mode using VSOC again. So VSOC is just a socket connection between the two guests on the system, the Android and the Linux. So you can really run anything over that. Graphics is VirtIO GPU. GNS, again, we run over console, so NMEA over text. Sensor HAL is VirtIO SCMI, so for gyroscope. This is something we and Google and ARM specified together in the Oasis Open Consortium. There's touchscreen input via VirtIO input, and the vehicle HAL again uses VSOC. Speaking of the vehicle HAL, now that you have taken Android and given its own guest, and you have that Linux sitting there, you can actually have a generic vehicle HAL, and that vehicle HAL will then communicate. Oh, go ahead. Is there a question? No question? Okay. So you can actually have a generic vehicle HAL in Android. So again, you can use the same Android not only across all SoC hardware platforms, but on the same hardware platform. You see here vehicle platform A and vehicle platform A. So this could be the same Qualcomm SoC, for example, but in different vehicles. So not only does the Trout Launch Target abstract away the underlying system on chip that you're using, but it also abstracts away the vehicle. So the communication networks of the vehicles could be CAN or Ethernet or LIN or whatever because of this generic vehicle HAL. And then you implement the specifics of the vehicle in the Linux guest. So again, you abstract away the hardware, including the whole car, not just the box that Android is running on, but the whole car. You abstract that away using the Linux guest and virtualization. Using Trout also helps you to keep the vehicle fresh. So let's look at the top here. So without VirtIO, as we said, you are totally dependent on the hardware vendor to get your Android. Again, there was talk, well, is Google going to support RISC-V? We don't know. When is Qualcomm going to support Android 13? Yeah, it's coming, but it's not there yet. And then in the future, a hardware vendor, you'll launch a car with a hardware vendor, and 2 or 3 years down the road, that hardware vendor is going to have a new system on chip, and they're going to discontinue support, including support for new Android versions for that new system on chip. So they basically are going to drop, they're going to drop Android support on that SoC like a bad habit. So basically you produce the vehicle with an Android version that is generally already 2 years old. So if you go into production in 2023, you're probably launching with the Android from 2021. So, next year Android 14 is going to hit the shelves, is going to go with public push, and you're probably going to launch your vehicle with Android 12. You see, for example, if you're launching on a Qualcomm platform, they don't even have Android 13 running there yet. So you couldn't even start development with Android 13 yet. But with VirtIO and the Trout launch target, you could already hit the streets running. You could already start with Android 13. So you're going to hit the streets running 2 years behind Android. Maybe a year later, you can do an over-the-air upgrade because the hardware vendor will provide a new version of Android. But then they're going to say, you know what, we're done supporting this old platform. And then cars are going to be driving around the street with, Android. Let's see, a year ago would have been Android 12. They're going to be driving around with Android 12 from now for the next 10 years, right? Now with VirtIO and Trout, the system can always be fresh because you're not dependent on the hardware vendor for Android. You can get it straight from Google, and because you have a VirtIO implementation on that car, you can just drop the latest version of Android in there. So first off, you have a version of Android when you hit the streets that is only a year old because you can start development earlier. Again, Qualcomm doesn't have Android 13. We're already working on Android 13 on Qualcomm because we're using Trout and not the Qualcomm specific launch target. So we're already a year ahead when we hit the streets. Then every year we can upgrade, Android and essentially be a year behind Android. So, in the worst case, you're never more than 2 years behind Android, right? It's a second before you upgrade, maybe you're 2 years behind in Android, but then you always are generally a year to 2 years behind and not, driving around with an Android that is 10 years old. So you can get all the latest features, fixes, upgrades to Android easily into your car. Okay, so my talk wasn't so long today, so let's draw some conclusions. Okay, don't be dependent on a specific Android Automotive OS launch target. You're creating a dependency on the hardware vendor for support in the short and even worse in the long term. So in the short term, a hardware vendor will probably support you, but in the long term, they probably won't. Going from one hardware to another is going to require major effort if you use the native implementation of Android. So all your applications, et cetera, probably you're going to have integration effort. You're going to need a team of engineers to do it. The maintenance becomes unmanageable depending on how many implementations of Android you have kicking around in your products. So the solution is to use the hardware-independent Trout launch target, which is based on VirtIO, to realize a software-defined architecture and remove the dependency on the hardware. If you want to know more, sorry, I sound like Starship Troopers. Go to this URL. I guess, Chris, you'll make these slides available so you can get all the details on the reference platform. There is a reference platform that we provide with Google, also along with the hypervisor and our VirtIO device implementation, where you can get this all up and running on. Currently, our VirtIO implementation supports the Qualcomm 8155 at the moment. So you can go get that here. So have a look at this URL and check it out.
Okay. So yeah. So if you send me a PDF of the slides, I'll put it up. I'll put it up tomorrow, and link it on the website.
Okay.
Okay. So thank you very much, Isaac. That was really informative. So anybody have any questions?
I had a question on the hypervisor bit. Who's managing and what hypervisor is this typically used at? And you're still depending on a hardware vendor to actually provide you with a hypervisor with the right functionality, right?
So we provide the hypervisor. Open Synergy does. That's what Chris had mentioned it. We provide what's called the Cocos hypervisor. And it's fairly easy. We do need a little bit of help from the hardware vendor, but not much. And since the hypervisor essentially relies on ARM v8 standards like PSCI to bring up the cores, and the usual hardware virtualization extensions that ARM provides, there isn't much porting effort to move the hypervisor from one ARMv8 platform to another ARMv8 platform. What's tricky is, of course, if you go to a new architecture like x86 or RISC-V or something like that. And then the VirtIO devices also are, maybe I can just put the architecture back up again so you can see it. So the VirtIO devices are not so much effort to port, but you are dependent on the hardware vendor or somebody to give you a Linux where you can put those VirtIO devices, at least with our implementation. Does that answer your question, Kevin?
Okay, I have one question of my own, if I may. I'm confused as to what the difference is between cuttlefish and trout.
I think Trout has certain things that would be for vehicle deployment, and things will swim from trout to cuttlefish. The main reason for trout is that we can be fast. So we work with a team at Google that is, the automotive team, and they often want to do things fast. Or without, let's say, the blessing of cuttlefish. So, for example, we really wanted Bluetooth badly. This is, Bluetooth is maybe a function that you wouldn't necessarily need in the cloud, but in a vehicle, you really want to have Bluetooth, right? So we wanted to have Bluetooth support. So we, with Google, implemented Bluetooth support, kind of a pre-version of VirtIO Bluetooth quickly, and got it into Trout. So I think the main difference between Trout and cuttlefish is Trout is just faster and more tailored to automotive needs. And there may be things in Trout like this vehicle HAL, this generic vehicle HAL that you wouldn't find in cuttlefish.
Okay, so trout basically has a different development cycle to cuttlefish.
Exactly.
Yeah, yeah. The hypervisor, is that open source, or do we need to license that?
So our hypervisor is not open source. You have to license it. So the Cocos hypervisor is not open source. You have to license it. We are working to put our VirtIO devices in KVM KMU, but then our VirtIO devices also aren't open source. So you need a hypervisor, and but you can use KVM KMU, and you need a VirtIO device implementation. I don't know if there's any open source VirtIO device implementations out there. Yeah, but we do, for interested parties, provide evaluation versions of our hypervisor and VirtIO devices.
Okay, anyone else? We've got a couple of minutes to spare here.
I had one other comment on the virtualization piece, or question, I guess. You might be interested in the power management side of things. At Plumbers, we had some discussions around the VirtIO handling for power management. So you may know that in Chrome OS, they're running in Chrome now. So you can actually run Android inside of Chrome OS, right? So today they're actually doing that in containers. Mm-hmm. One of the things we were discussing at Plumbers is they're actually trying to do that in VMs now. So actually Android in a VM, and that's how they want to run Android under Chrome OS. Yeah. Initial experiments have, however, shown that the power management pieces of that actually kind of fall apart because of the hardware support for power management, especially for ARM64 big little systems where you have fast and slow clusters and so on. All that stuff kind of falls apart when running under VMs. So there was some discussion of actually how to handle the power management pieces potentially with VirtIO devices as well. But that's more of, I guess it's more of an FYI if you want to follow some of that at Plumbers. There's no real conclusions of that, but the basic conclusion was that running Android under VMs under Chrome OS has still a lot of issues for power management.
Yeah, I mean, so one thing, the Android here doesn't have access to the physical hardware, so it has no driver, for example, to control the voltage regulators or the frequencies of the various chips, right? We are looking at potentially having over VirtIO Android be able to give hints about the governor and say, well, I would like to use the performance governor now, or I would like to use the saving governor now. Our focus hasn't been there so much, but we do recognize that there is a need. Generally, in an automotive setting, you're not so concerned about battery power. Of course, you don't want to you don't want to create more heat than you have to. But I would say that power consumption isn't as critical in an automotive setting as it is in a phone setting, where it is critical, and that is definitely a problem. The other aspect of power management where I would say we're more focused on is suspend to RAM, which is important, for example, for garage mode, or essentially putting the car in a low power state and having it wake up quickly, because Android does take a little while to boot. Also, virtualizing does increase the boot time a little bit. So we have worked on suspended RAM, and that does work. And we even have garage mode working, where Android can say, car, don't suspend, or box, don't suspend to RAM yet. Give me a few minutes to do my cleanup maintenance work, and then suspend. So that does work. But indeed, the power management, the voltage regulation, and the clock frequency of the cores right now is not possible under VirtIO.
Yeah, and it's even more complicated than clocks and regulators, because now with big little SOCs, you actually have this happening by the scheduler. The scheduler placement of tasks on the big cores versus little cores, based on how active they are and stuff, you need to map some of that information up into the guests as well, so they can do the right scheduling. And so there's all sorts of conversations on how to exactly map CPUs into the physical CPUs to virtual CPUs, if you want the guests to know about all this stuff or not, because it has power management consequences. So it's fairly complicated, and lots of options there.
It's tricky, and then if Android is sharing CPUs with another guest, it gets even more tricky.
Yes, exactly.
Yeah.
That's what made the Chrome OS use case was kind of unique, because if you just want to run one Android inside of one Chrome OS, you actually kind of have a easier problem. But to generalize that is pretty complicated.
Yeah, I mean, if you look at this setup here, let's say right now this Linux is portrayed as just a place, as kind of a DOM zero, a place to run the VirtIO devices. But often, customers, they just don't want to have this Linux sitting out here. They want to run their instrument cluster on there, or some other function, often an instrument cluster, right? So you've got to worry about, keeping this guy up and running. In fact, has more important than the Android guest you're running. Your Android guest, your IVI, infotainment is important, but your instrument cluster is even more important, right? So you need to watch out that, your Android infotainment system isn't messing around with your, slowing down your instrument cluster, right? Or here, if you have another virtual machine out here that's doing some safe function, I don't know, night vision, or sitting on the telltales of the instrument cluster, that guy's even more mission critical, and you don't want your Android clocking down his processors, for example. So it gets to be a pretty difficult problem.
Okay, it sounds like you guys need to talk offline about this. But yeah, it's an interesting consequence of virtualizing things. Yeah, just how virtual you're going to get. Okay, anybody else we have time for one more question, I think. Anybody else have anything to ask Isaac? Okay, it's gone quiet out there. Okay, well, I think that was an excellent, very interesting talk. Thank you very much, Isaac.